All right, guys, so this is going to be our second lesson for this week, adding and subtracting rational expressions. So let's go ahead and hop into it here. All right, so some essential understanding we need to know. So to operate with rational expressions, you can use much of what you know about operating with fractions. So to add or subtract rational expressions, you first find a common denominator, preferably the least common multiple of the denominators. To find the LCM of several expressions, factor the expressions, numbers, or polynomials completely. The LCM is the product of the prime factors, each raised to the greatest power that occurs in any of the expressions. So our first example here. So how to find the least common multiple, or your LCM. So what's the LCM of 12x squared y and then all that in the parentheses and 18x x y cubed and x squared plus 5x plus 4. So again, when finding the prime factors of each expression, we're going to take it separately here. So again, on the inside there, you would factor x squared plus 2x plus 1. And then in simplest form, you would get x plus 1 and x plus 1, which can be rewritten as x plus 1 squared. Now, when we want to look for the LCM for each of these factors out here, you're going to look for the what we have here, which would be, if I broke that 12 into two factors, that would be 4 times 3, because 4 can be rewritten as 2 squared. All right, 3 cannot be simplified. X squared is a factor in itself. So again, we're going to leave that as x squared, and we're going to leave y as itself. Okay. If we factored 18, that would be broken down into 2 and 9, because 9 can be rewritten as 3 squared. So essentially, we're writing these with powers here. Okay. X can't be simplified, and we're going to leave it as y cubed. When we factor x squared plus 5x plus 4, you should get the factors of x plus 1 and x plus 4. So you're trying to get these down into simplest terms with powers. Okay. Then from there, we're going to write the product of the prime factors, each raised to the greatest power that occurs in either expression. So essentially, every number that we see there, we're going to take the biggest out of all of those there. So here are both those 2's there. We have 2 squared and 2. Which one has the highest power? That would be 2 squared. So that's why they brought down the 2 squared. They both have 3's. Again, which 3 has the biggest power? That would be 3 squared. So they brought down 3 squared. Out of the x's, which one has the biggest power? X squared. Y, which one has the biggest power? Y cubed. Out of my x plus 1's there, which one has the biggest power? X plus 1 squared. And there's only one, x plus 4, so that's the biggest power. So it's just going to be x plus 4. Last step, combine everything on the outside together. So 2 squared would just be 4. 3 squared would be 9. So 4 times 9 gives us 36. Those powers can't be multiplied, so it's just going to be x cubed and y cubed, and we're going to leave the factors as they are: x plus 1 squared and x plus 4. So again, that's how we find the least common multiple. Find the biggest power that they have in common, and that's going to be the least common multiple. Okay. All right. Least common denominator. So very similar to what we just saw here. So the least common multiple of the denominators of two rational expressions is also known as the least common denominator of the rational expressions. You can use the LCD to add or subtract the expressions, which is what we're going to be focusing on today, adding or subtracting. So recall how you use the LCD to add factors here. So again, if we were adding 1/8 plus 1/10, just like we did before, we could break this down into the biggest in our factors here. So again, 2 is 2 can be raised to the power of 8, right? So 2 cubed would give us 8. Now that 10, when broken down, would be in the factors of 2 and 5. So notice there how both of these both have a 2. So again, when we look at this, we need to know that both of these, the common factors out of this would be 2 cubed and 5, because the 2 has the biggest factor of 3, and then 5, there's only one 5, which means that each one's going to have a 2 cubed and a 5. So when I multiply this 1 over 2 cubed, we're going to multiply it times 5 over 5, because again, that one doesn't have a 5. Now, on that second fraction there, since there's only 1 2, that means we're missing 2 more 2. So we're going to multiply that second one on top and bottom by 2 squared. Again, when we multiply 2 squared over 2 squared, it's like multiplying times 1, because anything over itself just reduces down to 1. So when that simplifies here, on that first one, 2 cubed, which is 8, times 5 gives us 40. 2 squared, which is 4, times 2 times 5 would give us also 40. So again, that gives us the same denominator there. And since our denominators are the same, then I can add the top part. 5 plus 4 gives me 9. And again, the denominator stays the same. So 9 over 40. So just like before, you need to have the same number of 2's and 5's on both for them to come out to be the same. Okay. Now, when adding rational expressions here, so if we are trying to add x over x minus 1, and again, plus 2x minus 1 over x squared plus 3, or minus 3x plus 2. First step, you have to factor the denominators. So when I factor x squared minus 3x plus 2, you should see that that factors down to x minus 1 and x minus 2. So if I look at both factors, what do they share in common? They both share that x minus 1. So for me to add these two, remember, they have to have the same factors. So looking on this one here, since they both share that x minus 1, that means that this first fraction right there is missing an x minus 2. So for us to have the same denominator, I'm going to multiply that first fraction on top and bottom by x minus 2. So on the bottom here, you notice now they have the same, and all I have to do on the top is just distribute that x into x minus 2, which gives us x squared minus 2x. Now that my denominators are the same, I can then combine that top part together. So if I combine that, that would look like x squared minus 2x plus 2x minus 1. And again, I can simplify that because negative 2x and positive 2x cancel out, which reduces down to x squared minus 1. Now, again, that is the difference of squares there. They're both perfect squares and it's separated by subtraction. So that should reduce down to, as we see here, x minus 1 and x plus 1. If I can simplify, I need to do that. And on top and bottom, they both share that x minus 1. So I'm going to cancel out x minus 1 on top and bottom. So in this instance here, my final answer is going to end up being x plus 1 and x minus 2. And just like we learned yesterday, if we cancel something out, then I'm going to set that equal to 0, and that's my restriction. So then this restriction, it should be x cannot equal 1. Now again, the other part that we look for here is on the other denominator here, which is still x minus 2, because remember, in our denominators, we cannot have that equal 0. So I also set that equal to 0. So our restrictions here are x cannot equal 1 and x cannot equal 2, because again, you just set that equal to 0 and solve for x. So there are your restrictions. And that part right there is our simplified form. Okay. And example 3, subtracting rational expressions. So just like before, your first step is to always make sure that you are factoring your denominators. Make sure they are in simplest form here. So in this instance, in that first fraction, I would simplify that down to x times x minus 2. And in that second one, that would reduce down to 2 times x minus 2. Since these both share x minus 2, remember, then they have to have the same factors on both parts there. So that means that this first factor is missing a 2, and that second factor is missing an x. Well, I would multiply the top and the bottom of that first fraction by 2 over 2, and that second fraction by x over x. So again, all that we end up doing there is, as we'll see, is that that denominator should be the same as 2x over x minus 2 on both. And then that 2 and that x will be distributed into the proper parts there. So we should have 2x plus 4, and then we should have x squared plus 2x. Now remember, we are subtracting this part here. So again, with my denominator the same, I can make it one big fraction, right? If that's the case, then that first part will be 2x plus 4 minus, again, this is why you have to put in parentheses here, because that minus needs to distribute into both terms. So what happens here is you should get 2x plus 4 minus x squared minus 2x. And from there, you combine like terms. Since I have a positive 2x and a negative 2x, those cancel out, and I should be left with negative x squared plus 4. Now, again, we don't like to have negatives in front of our x, so if I factor out a negative or a negative 1, because it's the same thing, I should be left with x squared minus 4, which I can use difference of squares on, so that simplifies down to x minus 2 and x plus 2, and as we can tell on top and bottom, they share that factor of x minus 2, so I would cancel those out, simplify it down to negative or negative 1, parentheses x plus 2 over 2x. Since I crossed out that x minus 2, I know that one of my restrictions will be x equals 2. And since there's only an x there, if I set that equal to 0, that'll also be 0. So those are my two restrictions, 2 and 0. And again, don't forget that negative sign. If you put negative or -1, it should give you the same answer. Okay. A complex fraction here. So a complex fraction is a rational expression that has at least one fraction in its numerator or denominator or both. So here are some examples. So again, a complex fraction is where we have fractions on both top and the bottom parts of our fraction there. All right. Again, these are just examples of what they look like. That's all. Okay. So how we're going to simplify a complex fraction here. So I'll give you two methods here to kind of pick which one looks easier for you. But again, both these methods should give you the same answer. So method 1 here, multiply both the numerator and the denominator by the least common denominator, which is what we just learned, of all the rational expressions and simplify the results. So here is our complex fraction here, right? So if that's the case, they rewrote it to where all we did was we found the LCD, which is what I was trying to say. Sorry, I'm getting brain tracked here. So if I look for the LCD here, then we should see that both of these have an X and a Y in common here. So again, what I would do is I would rewrite this by multiplying both the top and the bottom by X, Y. When I do that, we're going to use the distributive property here. So again, that XY will be multiplied into both the 1 over X plus the X plus Y, as well as the bottom part of the 1 over Y plus 1. Okay, so when we distribute that both into both terms, this is what it looks like. And again, then we're going to simplify because again, X over Y would be written over 1, which kind of cancels out a lot of things there. So that 1 over X times X plus Y leaves us with Y. And same thing here, that leaves us with X squared. On the bottom, we're left with X plus Y. And again, this cannot be simplified here. So this would be our simplified form. So that's kind of the first way of looking at it. The second way, again, same problem that we're looking at here. Combine the expressions in the numerator and those in the denominator, then multiply the new numerator by the reciprocal of the denominator. So all they're saying to do here is multiplying it by the reciprocal of the denominator. So if we look at that here, the reciprocal of our denominator is 1 over Y, which would be the same thing as saying multiplying everything by Y over Y. So if I multiplied everything by Y over Y, as we can see here, and that would go on the bottom because that's the only denominator we have there. On the top, we have a denominator of X and Y. So that means that I would multiply the first one by Y over Y, and then the second one by X over X. So again, we're just flipping where those denominators would go. So if I were to do that, that would give me the fraction of Y over XY, because again, that's what we get when we combine those. And in the second one, we would have X squared over XY. So if you notice in that top part there, now we have the same denominator. And the bottom part, since there's no denominator on that 1, it just gets multiplied by that Y, which leaves us with Y over Y plus 1 over Y. And since they have the same denominator, you can just make it one big fraction of 1 plus Y over Y. Now, again, from there, we would add these parts here. So again, anytime we have a fraction over a fraction, you can rewrite that as division. And as we see here, they just rewrote that. It's the first fraction divided by the first fraction, the bottom fraction. And then from there, remember, we don't divide fractions, so you have to keep, change, and flip. So when we keep, change, flip, we keep the first fraction the same. We change division to multiplication, and we flip the second fraction. Sign stayed the same. You just flip it. Once you flip it, then from there, you just multiply the tops together and you multiply the bottoms together. From there, you should get that you get, from there, you get Y plus X squared over, and again, what they did also is they kind of simplified some things here. As you can kind of tell, these both had a Y on top and bottom. Let me see if I can. So those Y's end up canceling out right there. And from there, we do see that we get Y plus X squared on top. And then we're left with, if I distribute that X into both of those terms there, it's going to be X plus XY, which is the same answer that we got from before. So either method you do here should give you the same answer. It's whatever method you think is going to be easier, okay? All right, so that's today's lesson, guys. We do have homework over this. And again, your homework should be due by Wednesday at April 29th by 11:59. Make sure you stay on top of your assignments. Don't let that fall behind you guys. And if you have questions, feel free to contact me, remind me, email me, whatever you have to do to get in contact with me. Feel free like you can, guys. All right. Other than that, that's today's lesson. You guys stay safe out there, and I'm here if you need me.